we're going to learn some basic skills that are going to be helpful for you as you take the statistics course. And we're going to start with rounding and scientific notation. So oftentimes when you're doing a calculation on your calculator here, maybe it's a fraction or you're dividing here. So let's say I'm dividing 5 divided by 11. Okay, and I hit return, and this actually is a repeating decimal. So some fractions, when you divide them, you get a decimal that terminates. So let me give you an example, like 3 divided by 4, 3/4, and that's just 0.75. And you can just write that down, right? The fraction terminates, 3 divided by 4, and that's equal to 0.75. And you're good, okay? But if you had 5 divided by 11, well, this is a repeating decimal, and you can't keep writing that on forever. This actually goes on forever, but you can't keep writing it. And so what you need to do is you need to learn how to round the answer. And so when you're doing the homework on the online homework system from the publisher, it'll often tell you round to 2 decimal places or round to 3 decimal places, whatever it tells you. Okay, so let me actually write this down. If I do 5 divided by 11, this is 0.45454545, and it's just going to keep going on forever. Okay, so if they say round to 2 decimal places, or what would be the same way of saying that is round to the nearest hundredths. Okay, so hundredths would be 2 decimal places. So kind of like like if I had 45,454, and so if this were a whole number, so and then I kept this going or something. Okay, this would be the ones place, the tens place, the hundreds place, the thousands place, the 10,000s place, and so on. So this number over here, this would be not the 1th place. There is no 1th place, but this is the 10ths place, like 5/10ths, which would be 1/2, 0.5. This is the hundredths place, the th. Instead, this is the hundreds place. This is the hundredths place, the thousandths place, the 10,000ths, the 100,000th, the millionth place. Okay, so when it says round to the nearest hundredths, it means round to 2 decimal places. So what I need to do is I need to round this number either up to 6 or back down to 5. Okay, and the way you decide is you go to the next decimal place over. In this case, it's a 4. Okay, now if this next decimal place over is 5 and above, then you're going to round this up to 6. Okay, but if it's below 5, so if it's 0, 1, 2, 3, or 4, then you're going to keep it at 5. Okay, so if I'm going to round to the nearest hundredths place, then I'm going to say 5/11ths is approximately 0.45. Okay, so I'm rounding to 2 decimal places, the nearest hundredths place. And I round it back down to 5 because this thing isn't 5 or above. And that's how you round. Okay? This means approximately equal to. So if it's exactly equal to, so if it terminates like 3/4, then I do a regular equal sign. But if I have to round on paper, I indicate to the person who's reading my calculation that this isn't the exact answer. This here means I rounded to approximately 0.45. Okay, the exact answer is 0.454545, so on. Okay, so 5/11ths is approximately 0.45. Okay, so now if I needed to round to the nearest thousandths place, okay, then this would be rounding to, this is tenths, hundredths, thousandths. So what that means is I'm rounding here to the third decimal place. So I'm wanting to round this 4 either up to 5 or back down to 4. Okay? And so I base that off of this number here. If this number is 5 or above, then I'm going to round that up to 5. If it's 4 or below, then I keep it at 4. I round it back down to 4. Okay, well this is a 5. It's 5 or above, so I'm going to round that up to 5. So if I round to the nearest thousandths place, then 5/11ths is approximately 0.45, and then take that 4 and I round it up to 5. So that would be rounding it to the nearest thousandths place. Okay, so let's try maybe a couple more of these. So let's say I'm going to do the square root of 35. Okay, now if the square root comes out equally, like if I do the square root of 36, 36 is a perfect square. 6 times 6 equals 36, and I would get 6. Or if I do the square root of 25, that would be 5. Or the square root of 64, that would be 8. So if it comes out evenly, that's fine, okay? But if it doesn't come out evenly here, what you actually get is an irrational number. So this isn't going to be a repeating decimal. This is going to go on and on forever, but it's never going to repeat. And they call that an irrational number. Okay? So we would have like the square root of 35 here is equal to 5.91607978, and it would keep going. This would be an irrational number. Okay? Oftentimes square roots end up being irrational. So if I wanted to round to the ones place, let's say, let's do this, let's round to the ones place. If I did that, then this would be approximately 6. Why is that? Because I need to decide, do I round the 5 up to 6 or do I go back down to 5? Well, it's based off of the next decimal place over, and that's a 9, and 9 is 5 or above, so I'm rounding that up to 6. Okay, so if I round that to the nearest, if I round that up to the nearest tenths place, okay, then I need to decide, do I round that 9 up to 10, which if I did round the 9 up to 10, that would make this a 0, and then you would have to carry, and that would make that a 6. Okay, now in this case, because this is a 1 here, I don't round that up to 10. I'm going to round it back down to 9. So this would be approximately 5.9. 5.9. That would be to the tens place. So if I round to the hundredths place, then I'm going to decide to round that 1, I'm going to round up to 2 because this 6 is 5 or above. So 5.92. That would be rounding to the hundredths place. Okay. If I round to the thousandths place, this would be 5.9. So I'm going to decide to round that back down to 6 because that's a 0. It would look like that. Or if I round to the 10,000ths place, that 0 is going to round up to 1 because this 7 is 5 or above. 5.9161. Okay, so if I'm going to round to the nearest 10, that's 10,000, so the nearest 100,000ths spot, I'm going to round to 1, 2, 3, 4, 5, to 5 decimal places. That 7 is going to round up to an 8. So I'd get 5.91608. And so now, and I wanted to go out at least. So let's round this to 6 decimal places, which is this one right here. I wanted to go out there because this is one where you kind of have to carry. So this 7 is going to round that 9 up to, oops, sorry. I'm not sure how long that was off of the screen there. But this 7 here is going to round that 9 up to 10, so I'd have to carry and make that an 8. Another way you can think about this is I'm going to round 79 up to 80. That's a way that you can think about this. So if I round this here, I'm going to get 5.916080. And that would be rounding it to 6 decimal places. Okay, so that's the idea of rounding here. Whenever you do a calculation where you divide and you get a repeating decimal, or you do like a square root and you get an irrational number, then you're going to have to round your answer to so many decimal places. And usually when you're working on the homework, the online homework system is going to tell you how many decimal places you need to round to. And if you don't round correctly, you'll get counted wrong. So you do need to learn how to round. Okay? So another thing is scientific notation. So let me give you an example. When you do some calculation, so let's say I do 32 divided by, and we'll say 84 million, okay? And so in other words, 32 divided by 84 million is going to be a very small number. Oh, wow, and it did it. And I think I know the reason for this because I have it set differently. So I'm going to do my norm, and I'll do norm 1. Okay, so let me write this down. So 32 divided by 84 million. And so what happens, and this often happens like when you're doing a probability or something, and this is a very, very small probability, okay? This is going to end up being a very, very small probability. This fraction is a very small number. It's like taking a pie, splitting it into 84 million pieces, and taking 32 of those pieces. It's a very small fraction of the pie. Okay? So oftentimes when you put a calculation in and the answer is very small, it's going to give it to you in scientific notation. And what this means, so you can actually see it here. It's like 3.8095238 times 10 to the negative 7. Okay, and that's what that is. It's hard to see here, but this calculator actually says times 10 to the negative 7. Okay, some calculators will say E minus 0.7. It'll use instead of times negative 10 to the instead of times 10 to the negative 7, it'll say E negative 7. Okay? So that's one thing I like about this. So the way you would write this in scientific notation, so it would look like this. This is scientific notation. Oftentimes, when you're using scientific notation, like in a textbook or whatever, they'll do like 3.8, and then they'll maybe round the 0 up to 1 times 10 to the negative 7. So in other words, they'll only use 3 digits here, which this is approximately equal to this. So it's not giving you as many decimal places. Okay, it's approximately this. And so let's actually look at that one. So what this means here is that this negative 7 means that this is a really small number. Okay, and so it means that you have to move the decimal point over 7 places. And now to move that over 7 places, I actually have to have some zeros, okay? I'm going to have to add 6 zeros so that I can take this and move it 1, 2, 3, 4, 5, 6, 7, and that would be my decimal point. So I would actually get 0.0000000381. Okay, so this would actually be the number. But oftentimes when it's that small, it helps to do scientific notation. Okay, and the reason for that is because when they're this small and you have a bunch of numbers, it's hard to compare them because it's hard. You got to know how many zeros are in each one. But when the numbers are written like this, you can compare this exponent. And so if I had this number and I had another one that was okay. Well, let's say this was 392. So you might look at these and say, oh, this one's bigger because this is 381, that's 392. But that would not be the case because this has 1, 2, 3, 4, 5, 6. This has 1, 2, 3, 4, 5, 6, 7, 8. So if I move this, I would have to move this back 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And I'd get 3.92 times 10 to the -9 right there. And so I could compare these two and I would know this is the smaller number because it has the smaller exponent. -9 is less than -10. So this, you're moving the decimal point over more places to get this really, really small number. Okay? And you could also have positive exponents. Like if I did this, if I did 56 to the 18th power, let's say, I get a really large number. And what this is this number is, so 56 to the 18th power. This is, I have like 2.933489149 times 10 to the 31st power. So this is a positive 31, and so that means this is a really large number, and it means I got to move this decimal point over 31 places. Let me actually get a one that's a little smaller. 56 to the 8th power. There, we'll do that. 56 to the 8th power. This is 9.6717311157 times 10 to the 13. So I'm going to move this over 13 places. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I got to move it 13 places. So then I got to add some zeros. So here I moved it 9, then 10, 11, 12, 13. So in other words, if I move this back to here, I'm moving it 13 places. 1, 2, 3, 4, 5, 6, 7, 8. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this would be like this. A really large number. 100, 1,000, million, billion, trillion. So that would be in the trillions. Okay, and these zeros here are probably because this here only goes to so many decimal places. And so if you actually found the exact number, there would be more digits here, very likely. Okay, but they just didn't have enough space to include that on the screen. And so this is really getting rounded to the 10,000th place. So this is actually rounding it to that place, and that's why those are all zeros. Okay, that's the same here, because if I use this number, I could do, there's the 381, right? But I could use this number, 380952381, and so now I get this more exact than what I had before. Okay, but it's still not probably exact, because there's probably more decimal places, okay, that go on. Maybe it's a repeating decimal. Okay, so that's why oftentimes scientific notation, you just include a ones place and 2 digits, and they just figure that that's going to be good enough. Okay. So that's the idea behind scientific notation. We're not really going to use it. The only reason for bringing it up and practicing a little bit with it is that when you do calculations on your calculator, things may come up in scientific notation. And when you see that, you need to recognize, oh, that's scientific notation, right? And you don't just put like 3.819 or something. You don't just put this number. If you don't have this number, then you're not getting the right value. So the answer to this isn't 3.809. Okay, it's this number. It's a really, really, really small number. And so this portion of it is very important. Okay, and so you need to be aware of scientific notation.